Okay, so we're going to take a look at exercise 1 on page 66 of your workbook here. And this is another example of the type where we're given a formula for a function and we're going to try to use the derivatives of the function to figure out some information about it. Okay, and part A is asking us to figure out a couple of things, where the function is increasing and decreasing and where it has local max and local min values. Okay, and you might remember from the previous example that we did, all of these questions can be answered using the first derivative. Okay, so what we'd like to do is to make a first derivative sign chart, and this is a nice opportunity to review that process. All right, and so I'm going to start by just up here going ahead and calculating the derivative for f. Okay, that's just going to involve the power rule. So 3x squared plus 6x minus 24. And we're going to take that and set it equal to 0 to find our critical points. All right, and you might notice in this case that this factors. We can pull a 3 out of there. Okay, and that factors further into 3 times x plus 4 times x minus 2. Now that it's in factored form, hopefully you can look at that and see that we're going to get two solutions. Either x is going to be negative 4 or x is going to be 2, looking at those two factors. Okay, so the sign chart that we make, we're going to start by just kind of marking those 2 points that we found, negative 4 and 2. This is the first derivative that we're talking about. Okay, and so as we did before, we're interested in determining whether the first derivative is positive or negative in each of those 3 zones in our sign chart. Okay, so we're going to pick some test values. Okay, so we need a number that's a little bit less than negative 4. How about negative 5? Something that's between negative 4 and 2. 0 is a nice number between negative 4 and 2. And a number that's a little bit bigger than 2. Maybe 3. Okay, we're going to take those test values and one at a time plug them into the derivative, starting with negative 5. Okay, I'm going to use the factored form of the derivative, which is sitting here. We'll just take negative 5 and plug it in there. Okay, and you can do this arithmetic on your own. 3 times negative 5 plus 4, that's 3 times negative 1 times negative 7. We've got a positive times a negative, which gives us a positive number and puts a plus in that first part of our sign chart. Okay, and then we move on to 0. 3 times 0 plus 4 times 0 minus 2. Do that multiplication. 3 times 4 times negative 2. This time we get a negative number. Okay, and then finally we come to 3. 3 times 3 plus 4 times 3 minus 2. This time, all 3 numbers are positive. Okay, and so we're going to get a plus sign there. Okay, and the signs in that chart basically tell us about where our function is increasing and decreasing. Okay, so we can look at that chart and notice that we've got 2 zones, 2 intervals where we've got plus signs. That's where our function is increasing. Okay, so increasing from negative infinity to negative 4. That's the first of our zone. And again, where that second plus sign is from 2 to infinity. Okay, and then where are we decreasing? Well, that's the one place where we see a negative sign. So we're going to be decreasing between x equals negative 4 and x equals 2. Okay, and so we've answered the first part of this question, and we're ready to move on and answer the question about local max and local min. Okay, well, we can answer those questions by kind of examining our chart and reminding ourselves what that means. Okay, so I'm going to focus first on the number -4. That was one of our critical points. Notice that we've got a plus sign to the left and a minus sign to the right, which tells us that our function is going up to the left and down to the right. Notice that we've got a local max in the middle. So f of -4 equals some number that we're going to figure out is a local maximum. So we'll leave some space so we can do that calculation in a minute. Okay, and then if we move over to the number 2 in our chart, we can see that we're going from a negative sign to a plus sign. Okay, so we are decreasing to the left and increasing to the right of 2. Notice that that looks like a little local minimum, and so we've got a local minimum at 2. So f of 2 equals some number that we're going to calculate as a local minimum. Okay, and now it's just a matter of taking these two numbers and plugging them into our function to see what they are. Okay, if you look at the top of the page, there's our formula for f of x, so we just need to plug those two numbers in there. Minus 10. And I'm going to leave that calculation to you. You can ask your calculator. And that's going to turn out to be a positive 70. Okay, do the exact same thing with 2. Just plug 2 into all of those, and you're going to get an output of, you can double check me on this, -38. Okay, that's our local minimum. Put all of that together, and we've got an answer to part A. Okay, and in the next video, we will